welcome to the class. It's going to be fun, right? I really like R. I really like teaching about R. I really like Stata too, incidentally. Stata is a very powerful program, has a lot of really great features, backed by a good company. Um, and so between R and Stata, right, you really can't lose. Again, for those who just joined, my name is Andrew Miles. I'm located up in the Toronto area. I'm at the University of Toronto, and yeah, we're gonna learn some R. So, most of the time that we spend together, we won't be using slides. I don't think it's the most effective way to learn these. We are going to have a couple slides at the beginning just to kind of lay some groundwork. Um, so, 80% of the slides we're going to see in the next couple of minutes, and it's not that many. Um, all right. So first off, why are we here, right? Like you all have reasons for coming and wanting to learn about R. And if we had more time, I would love to hear those, but we don't. So I'm just going to assume that you are motivated to come in here and learn some really cool data analysis in R. So our time together is relatively short today and tomorrow. So we're going to focus on the basics, which I think is generally a good thing to do anyway. We're really going to focus on things that I think will set you up for success as you inevitably move on from here and try and use R for things that are more complicated than the things that we're going to be able to cover together. So we're going to really focus on figuring out basic data manipulation, some very basic statistical tasks, like how do we do a t-test, how do we do a linear regression in R, and then spend some time on practical issues, right? How do you write code that's good, right? If you have been writing lots of Stata code and you've developed good practices there, all of those will transfer over here. How do you get help, right? You're going to need help probably during this course. You're certainly going to need help as you try and figure out how to do things after this course. So we're going to talk about where do you find help for R? How do you read the help files and so on? And then really just try and get an understanding of R's approach to data handling and data analysis, which in some ways is fairly similar to Stata. And in other ways, there are some differences which could throw you for a loop. But that's why we're here. And then, of course, I'm a big believer in the idea that practice makes perfect. And so we're going to do as much as possible within the time constraints that we have. Repeats the core concepts. We'll do it again and again and again. Now, I have a couple of pieces of advice about how to make sure that you are learning as much as possible during these next 2 days. The first one is to code along with me. This course is designed not as a I talk and you passively absorb sort of course. It's really designed to have you writing code along with me. And so the way most of our time will be spent is I will sit down, I'll open up RStudio, and I'll just start typing code, and I'll type comments that explain the code, and I will talk about the code, and I'll be pacing it such that you can write the code along with me. So that way, at every step along the way, you're able to have the code, make mistakes in the code, work through the mistakes in your code, see what the code does, and so on. Now, an important point here is that I think the best and fastest route to knowing R is really trying to learn R from the ground up. It's a lot like learning a language. And while there might be some translation between a language that you know, aka Stata and R, at some points, that's not going to be the focus, right? Now I'm going to show you here in a minute where Stata sort of pops up in this course. But what I'm not going to be doing is, opening up Stata and opening up R side by side and being like, here's how you do it in Stata, here's how you do it in R, because you know how to do it in Stata. At least I'm assuming that you know how to do it in Stata. And what we really want to do is figure out how to do this in R. And then Stata is going to pop up in a couple of different places. One, as I explain things, as I explain concepts, as I try and point out differences between R and Stata, with the goal of helping you avoid some of the hurdles that you might otherwise run into, right? We want to eliminate as many of the easy to avoid mistakes as we can, so that we have time to focus on the little errors and coding issues that are likely to crop up for all of us. Okay, so let's go ahead and open up RStudio. So I will open that up and then share that with you. Okay. So this is our studio. A couple of things that we're going to want to do here. First, let me see if I move this over here. If you come up along the top, there is a menu called File. And if you click on that and come down here, under New File, there's just a whole bunch of different file types. And these are, again, all the different sorts of file types that RStudio will allow you to create. Again, RStudio is not R. R is actually, RStudio is a front end that sits on top and makes R easier to work with. But it also does a lot of things other than just allow you to work with R. Hence all of those different sorts of file types. So again, this is the file menu, new file. What we're going to be working with in our course is just an R script. This is what R calls its coding files. It's the equivalent of a do file in Stata. So let's go ahead and open up an R script. Oops. All right. Now, you'll notice that RStudio is laid out in a couple of different quadrants. Typically, there are 4 quadrants. What you're seeing right now on my screen are just 3 quadrants because I have one of them maximized, right? So I can pull that down and we have 4 different quadrants. Now, this takes up a lot of screen real estate. So it's often nice to work on a larger monitor if you can. And we're going to be introduced to these different quadrants and what they do as we move forward. So I'm not going to talk about all of it now, but I do want to point out a couple of things. Over here is our script file. This is like our do file. Over here is our console. And this is where we can either enter commands directly. It's like the command line in Stata. And there's also where the output will appear. The environment I'll talk about in just a second. And then over here, there are a couple of different tabs in this pane, which allow you to access different things. So we're going to talk about help files a little bit later. There's a tab for seeing and managing the extensions or the packages that you have in R. What I want to do right now is just show you, I believe by default RStudio actually has the script over on the left and the console over on the right. So if you want your setup in RStudio to look like mine, if that'll make it easier to follow along, I'm going to show you how to do that. If you don't care, then you can send your mind to La La Land for the next 30 seconds. So if you come up here to the Tools menu and go down to Global Options, so that's Tools, Global Options. There's just lots of different options in RStudio. Again, you can play around and explore those later. The one that we're going to look for down here is called Pane Layout. And this just allows you to customize which of those 4 panes contains which information. So if you want yours to match mine, then in the upper left corner, you have files, plots, packages, etc. The upper right corner is environment history, etc. Bottom left is console, and bottom right is source. Now, again, totally up to you whether you want to try and match what I'm doing on my screen, but if you wanted to change that around, this is the way that I have it set up. After you're done making changes, you come down here to the Apply button, and then things will update. All right. So that is RStudio. Now, I want to make a quick And I'm gonna switch out here, go back to the slides for just a second, and talk about a particular distinction that's going to be important as we move forward. And that's the distinction between what you can call base R and the tidyverse. So R is a program. It's been around for quite a while now. It comes equipped with a full suite of functions to manage most of your data analysis, analyses, and these types of things. Most other R packages are written using the functions that R comes equipped with. Collectively, that is referred to as base R. Base R is highly functional. I used it for many, many years. But in recent years, probably the last 10, maybe a little more than 10 years, there has been a movement among some folks who use R to create a collection of packages with a very specific philosophy. And collectively, those packages are called the tidyverse. So again, this is from the web page for the tidyverse. They say, the tidyverse is an opinionated collection of R packages designed for data science. For our purposes, there are two reasons why you need to know this distinction. One, because sometimes the way that the tidyverse approaches a particular data management task is actually quite nice. It can simplify our lives. And in this course, I want to give you just a good set of tools to be able to do good data analysis. And so because of that, sometimes we're going to be using some of these commands from the tidyverse. I'll also be using quite a bit of base R because you really need to know base R in order to understand how R works. And again, many of these other packages that you will use are written using base R. The other reason you need to know about the tidyverse and this distinction between base R and the tidyverse is that people use the tidyverse. And so regardless of whether you end up loving the tidyverse or not, you're going to run into it. And so you're going to need to know this distinction so that you can navigate the online environments that you are bound to find yourself in after this course as you figure out, look for help on how to do this or that in R. Any questions about these distinctions so far? Okay, now I will make it clear. When we're using something from the tidyverse, I'll be like, hey, this is coming from the tidyverse, which from your perspective just means that you need to make sure that you have loaded in the appropriate packages in order to use them. But again, I'll guide you through all of that. Okay, so let's get a little meta for a minute here. I want to talk to you about the basic structure of R. R is something that in programming circles is known as an object-oriented language. Practically what that means is that everything that you use in R, the data that you work with, the fitted models, regression models, anything like that, all of these are taken and they are stored in objects. And when you want to do things in R, you do that by finding those objects and manipulating them in some way. So probably the easiest way to see how this works is to look back at RStudio. So let's shift over back to RStudio for a minute here. Now, what we're going to do is look up at this environment tab up in the upper right corner. And you'll notice that there's this little drop-down menu here with the three colored squares that says global environment. Your global environment is like your user workspace. Anytime you bring data into R, anytime you fit a regression model, anytime you really do anything, that's going to end up here in your global environment. So the global environment is one of the places that R finds objects. These will be the objects that we create. So when in just a minute, we're going to read in some data that's going to get stored in an object, and we'll see it appear up here in our global environment. The second place that R finds objects are in these packages that I've mentioned before. Again, packages are like extensions to R. If you click on this menu here, you'll see that the global environment is up here at the top, and then underneath it says package stats, package graphics, etc. These packages are the ones that are standard in R. That these collectively are base R, that base R tidyverse distinction I talked about. This is base R right here. And these will load automatically anytime you start R. For our purposes right now, these packages are generally collections of other R objects. So if we click on package stats, you'll see that there are all of these commands in there. But in R, these commands are actually just other R objects, which is perhaps a little wiggy to think about. And you can go very far in R without necessarily grasping that distinction. But I did want to make that case, right? These packages are just collections of R objects, typically functions that will allow you to do different things in R. All right, so let's go ahead and get started. Let's import some data. So what we're going to do here is I'm going to come over here to my script.
Sorry, Andrew, do you mind? There's a quote. There's a question in the chat that I maybe now is the time to address.
All right, let's take a look here. So Betsy, right, has this question about data frames and not recognizing data frames. So data frames are R's basic data structure for storing data. And we're actually going to talk about those in a few minutes here. But the short answer is it depends on the situation. Yeah, unfortunately, I can't give a more specific answer than that without knowing the particular situation here. So maybe what we can do is during the break, Betsy, can I come back and then you can give me a little bit of information about like exactly what was happening there, and then maybe I can sort of troubleshoot that. Or perhaps as we run through, you'll find that this, as I present the material, that will resolve it. But again, it's a great question, but it's potentially a bit more complicated. And so I'll circle back. If I forget, please hit me again in the chat when we go on the break and say, hey, Andrew, you said we'd talk about this. All right. So let's go ahead and import some data here. So what I'm going to do is I'm going to move this up just so we have a little more space. We're going to import data. Now, you'll notice that I use this hashtag here in my code file. Hashtag is R's way of commenting out lines of code. It's the equivalent, I believe Stata uses like a single star, which will allow you to comment out a single line of code. R does not have an equivalent to this, right, in Stata, which would allow you to comment out several lines of code. However, if you do have several lines of code that you need to comment out, you can highlight them. And then if you come up to RStudio's menu, there is a menu called Code. And if you scroll down, there is a option here to comment or uncomment lines. That will allow you to comment or uncomment multiple lines at the same time. So again, hashtag just allows you to write notes in your code. My encouragement to you is to write lots of notes in your code. Anything that you need in order to understand the code that you're writing. So we're going to go ahead and import some data. Now, the first thing that we want to do here, just to make our lives easier, is we need to tell R where that data file is located, the data that we want to import. Now, turns out the problem is the same in Stata. Anytime we want to import data, Stata needs to know where on our computer that is. And there are a couple of different ways to do that. Some of you might be used to going up and using the menus, right, to come down, and then you just sort of point and click your way to the data. RStudio allows you to do that. How to do that is in the notes. I'm not going to show you that live because I actually don't think that's best practice. What we really are aiming to do is to create a code file that allows you to reproduce your code with minimal changes. That doesn't rely on you pointing and clicking things, because those point and click doesn't get recorded in your code file, right? And if you want a code file that you can understand later and that other people can understand, we want everything to happen in the code file. So what we're going to do is we're going to use commands to import these data. But first, we're going to tell R where our data files are located. And we're going to do that by setting the working directory. So we're going to set the working directory to tell R where our data files are located. So to do this, come up here. We're actually going to do it via the menus the first time, just so that we can get the code that we can then use as we move forward. So if we come up here to the session menu, there's an option that says set working directory, and then we're going to choose directory. So again, that is the session menu, set working directory, choose directory. And again, what this is we're going to choose a folder which R will then automatically look for anytime we ask it to find a file on our computer or to write a file to our computer, right? This will be the default folder. So if we choose directory, it will pop up a window on whatever kind of window your operating system uses, Windows, Linux, etc. So to show you what that looks like on mine, right? So you can see RStudio in the background. It's popped up this window. It allows me to navigate around using stuff that's familiar on the computer, these like the Windows system. What I want you to do now is to find wherever it is on your computer that you stored that course folder, that R for Stata folder. So for me, I stored that on the desktop. You'll see that the folder is right here, R for Stata. Again, point and click your way, find it on your computer, and then click open. Now, when you do that, you'll see that a line of code appears down here. This is the code that's actually doing the work under the surface, and you can copy and paste that code up here, into your code file, so that the next time you need to set your working directory during this course, you can just run this line of code. Now I'll note all of this little section of the code, that is going to look different on your computer. This is essentially the address on your computer where that folder is located. So don't worry about that. This is something that's called a file path. If you're familiar with file paths, you're going to be like, Andrew, why are you talking about this? If you're not, it might seem like mumbo jumbo. But the key here is what we're doing is pointing R towards a folder that it will now look in by default anytime we ask it to read some data in. Any trouble setting the working directory? The next thing that we do isn't going to work unless we've done this. So I just want to make sure that everybody is on board. Awesome. Once we've set the working directory, we can read in some data. Now, I'm about to say something that you will hear me say many times during this course, which is R is a very flexible language, which means there are many ways to do almost any task. That is both liberating and a bit frustrating, particularly if you're coming from a package like Stata, where there's much more a standard way of doing things, right? Like you recode variables using the same couple of functions all the time. R is much more like the Wild West as far as that's concerned. It's open source, so people can and do come up with different ways to do things. They think it's that they think are better to code data, and so there's lots of different packages out there that do lots of different things. Now, of course, you can make extensions in Stata as well, but my impression is that those aren't nearly as widely used, they're not as widely used in Stata as they are in R. R sort of depends on these external packages to a much heavier degree. That's a long way of saying there's a lot of ways to import data in R. I'm going to show you the one that I think is by far the easiest, at least right now. Maybe they'll come up with something better in the next couple of years. So let's import, we're going to load a package called Rio. Now, Rio is one of the packages that you should have installed before joining the course. It stands, I believe, for R import output or something, or input output. It's basically a way of importing and exporting data in R. Now, the way to load a package in R is to use this command called library. If it's helpful, you can think of the different packages that have been downloaded and installed on your computer as sort of sitting on your hard drive in a library, and then the library command goes and checks out the package and allows you to use it during your R session. Now, here is a difference between R and Stata. In Stata, you install an extension using like that SSC install command, and then it is available anytime you start up Stata. You don't have to do anything special to access the commands. That is great for ease of use. That is not the way that R works. Anytime you restart R, it will start with a fresh session. It'll just have, again, we looked up here in this environment tab, it's just going to have these basic packages ready to go. Now, that does mean it's a little extra coding for you. You have to manually tell R in your code file which packages you want to work with before, anytime you open up R. The advantage to this, though, is that your code is much more reproducible. It is very clear from looking at your code file which dependencies and which external packages your data analysis is using. Whereas in Stata, if you've installed something, you can just use that command directly in your code file. And if you then go back and look at it later, or you share that code file with someone else, it's not obvious which of those commands are based on these external packages. So again, it's a bit of a trade-off, a bit more typing, but there's also a reproducibility and I think a clarity that comes from having to load these packages every time you start up R. Now, so the basic rule here is load a package once per R session. As long as you haven't shut down R and restarted it, the package should still be loaded. All right. So let's go ahead and run this line of code. You can run a line of code by selecting it and coming up here to this little button that says run. You'll note as well that if you hover over this line of code, like a tiny little tooltip appears. You probably can't read that, but what, at least on my screen, hopefully you can read it on your screen, because it contains a keyboard shortcut that is specific to your operating system, which then allows you to run lines of code without having to actually come up here and push this run button. So I'm using a Mac, so on mine it says Command Enter. I believe Control Enter will work on most systems as well. So I'm just going to go ahead and highlight this line of code and click Command Enter, and you'll see that over here in the console, the line of code pops up, right? So it's moved from the script file, it runs in our console. Now, chances are when you loaded the Rio package, it said something like, hey, these suggested packages are not installed. It might have typed them out in a rather unnerving red font. I can't do anything about the red font, but I can tell you that this is meant to be a helpful message. Just because it's written in red doesn't mean that something has gone wrong. Basically, what it's saying is, hey, the Rio package can actually do a bit more if you were to install these additional packages, right? That'll extend the functionality of the Rio package. However, they aren't installed by default. So if you want to do that, here you go. So it's just giving you sort of a like a public service announcement about how the package works. But there was no error. There wasn't anything that said, you know, the Rio package failed to load, or there is no package called Rio, etc. So we know that the package loaded successfully. One thing that you can do to double check this is wander over here to this Packages tab. If you click on the Packages tab, it will show a list of all of the packages that are installed on your computer. Now, chances are you have different packages installed on your computer, probably fewer packages than I have. But if you scroll down here, we can find the Rio package. Again, there's a short description of the package as well as the version number. But the important point here is that there's a little check mark next to that package. That tells you that the package has successfully been loaded. Incidentally, if you wanted to, you could actually check and uncheck packages here, and the appropriate R commands to load and unload those packages would appear down here in your console as well, right? So if you ever forget how to load a package, you can actually just come in here and be like, oh, let's, click the reshape package, and it will pop up the command down here. And when you unclick it, it will pull that package out of memory. All right, so that's loading the Rio package here, which again, what this is going to do is allow us a nice simple interface for importing data. So we'll say, now we can import the data. So what I'm going to do is I'm going to type out the line of code that will import the data, just copy it down, and then I'm going to go back and talk about it to make sure that you understand exactly what's happening. All right, so this is the line of code here. And it has two parts. Part number one is this over here. The command itself, again, in R, these are called functions, though you could sort of use the terms interchangeably. Stata uses commands, R, we call them functions. The command itself is called import, and then everything inside of these parentheses is just information that we give to the function import to get it to work the way that we want. So what import does is it reads in data and it stores it in a data frame, which again is R's standard data structure for holding, your classic rectangular data, rows and columns. We then tell import which file we wish to import. We're going to import a file called binary.csv. It's in your course folder. R knows where to find binary.csv because of this line of code up here. We have set our working directory, and as long as it's pointed to our course folder, it should be able to find binary.csv. Now, this will import the data. It will store it in an object called D. So this thing here in the middle, this equal sign, is what's called an assignment operator. So the way to read this entire line of code is, hey, what I want you to do is import some data and then store that data in an object called D. Again, R is an object-oriented language. We do things by creating objects and then working with those objects. So in order to get data into R, we have to create an object for it to live in. So when we run this line of code, and again, remember, you can highlight it and hit run up here, or you can just use the keyboard shortcut. And if you're selected in a single line of code, you actually don't have to highlight that entire line of code. You can run a single line of code just by having your cursor in it and using the keyboard shortcut. Now you'll see again over here, the code is shown up, no errors have appeared, and this tells us, or at least gives us a good clue, that that line of code has executed correctly. If we now pop back up here and take a look at this global environment, you'll notice that it's no longer empty. It now says that we have an object called the D. It recognizes it as a data object because it's a data frame. It says it has 400 observations and 4 variables, and you can click this little doohickey on the side, this little sideways arrow, and it gives you some information about the variables in this data set. Now, you could also have written this command like this. Now, what I've done is I've just copied and pasted it. The only thing that I've changed is this right here. It kind of looks like a leftward facing arrow. This leftward facing arrow and this equal sign, they're both assignment operators and they work the same, right? So which you use is really your preference. What you're going to see most often when you look at help files online is this sideward facing arrow. Except in this course, I don't like it. I think it's extra typing. I just, for whatever reason, I think it looks tacky. So I'm going to use this equal sign, but these two do exactly the same thing. And you are welcome to use whichever one you prefer. So this does exactly the same thing with a different assignment operator. Now, the last thing I want to show you here, let me make a little meta comment here about import. The reason I like this import command so much is because it accomplishes 2 tasks for you that can otherwise be kind of a pain. The first one is import will allow you to read in data from lots and lots of different file types, including Stata DTA files. All you have to do is, write the name of the file with the appropriate extension. And as long as it's one of the many file types that import knows how to recognize and knows what to do with, it will recognize the file type for what it is and then read it in. The second reason I like this is it takes all of the idiosyncrasies of all those different file types and it trims off the parts that don't really work well in R, creates a standard data format. So no matter what type of data file you're reading in, you get something that you know how to work with in R and that will work well in R out the other end. Okay. I'm going to show you one other quick thing that you will occasionally see. And that's how you can make use of a package using a package prefix. Now, again, this isn't strictly essential, but it is something that you will see from time to time. And so I wanted to show this to you. Again, I'm going to type out the code and then I'll explain what it's doing. Now you'll notice that this line of code here is identical to that code that we originally created or that we originally wrote up here. The difference is this bit here, this Rio : this is what's called a package prefix. And what it allows you to do is it allows you to access the functions that are inside of a package without actually loading in the package. Now, again, much of the time, when you want to work with the functions in a package, you're just going to load the package in because you want to just easily access all of the functions. Occasionally, there's going to be like a single function that you occasionally need to use, in which case using a package prefix allows you to not load the entire package into memory. So this package prefix will say use if you don't want to load the whole package into memory. Now, of course, in this case, we have already loaded the Rio package, so this package prefix is redundant. But if we had not loaded the Rio package and we try and run this line of code, R would say, I don't know what this import function is. And that would be a clue to us that, oh, import is actually something that comes from a package. I need to load that package first. If we use this package prefix, that line of code would run just fine, even if, in fact, I'm going to uncheck the real package. The real package is no longer loaded, and this line of code will run just fine. Now, I'm actually going to reload the real package because we're going to use it a little bit later. But yeah, I just wanted you to see this package prefix. Some people actually like writing this as well because it makes your code extra, extra clear. It is always clear where all of your functions are coming from. Again, I tend not to do that. I'll just load it up at the beginning because, you know, I got to balance out clarity and ease of use. Oh, one other thing that you might have noticed. I have 3 lines of code that do the same thing. You might be wondering, well, Andrew, you just ran that line of code, and you ran that line of code, and you ran that line of code. So how many data objects have we created? Well, if you look up here, we still only have 1 data object. And the reason is R will replace objects if you ask it to. And this is a pretty clear difference between R and Stata. Stata is very protective of its data. It's very protective of its variables. If you try and create a variable that is already created, it will say no, right? Like some of the most aggressive messages I've ever received from software, I think come from Stata when you try and read in a data set when data is already in memory. For instance, it says no, data in memory will be lost, right? Like very in your face. And you have to specifically tell Stata, get rid of this variable so that I can create a new version, or get rid of this data so that I can do something else. R does not do that. R assumes that you know what you are doing. And so if you create a data object called D, and then create another data object called D, it assumes that you know that you're about to overwrite that original data object, and that you know what you're doing. Now, depending on your coding preferences, this is either terrifying or it is a wonderful feature. In my opinion, this is a wonderful feature. One of the things that has annoyed me when I work in Stata is when I'm, creating code and I'm troubleshooting my code, and so something doesn't work quite right. So I've created a variable that didn't create it quite the way that I wanted it to. Then if I want to go back and try it again, I have to drop the variable and then come back and try and recode it. And that's like an extra step, and I really don't like that. And but here I can just run the line of code. If it doesn't work quite right, fix the code, run the line of code again without having to go through that extra step. But again, depending on your coding preferences and style, this is either something that will make your life a lot easier, or something that you need to watch out for. Okay, that's all we're going to say about data import. I'm going to quickly show you how to export some data, just in case you might want to do that. And this is fast. This is like a minute, because you can also use the Rio package to export data, again, to many different file formats. The command is called export, and it works like this. So export will export a data object. The first thing that you list is the name of our data object. I've called my data object D. And then you need to tell R what file you want to store that data object in. So it's going to write the data to some kind of external file, and it will read the extension that you give it, and it will create the appropriate type of file. And it can create, again, many types of files. Once I tell you how to access R's help files, you can actually go look, and it lists out all of the different file types, but it covers all of your standard, major statistical packages, Stata, SPSS, SAS, etc., common things like CSV files, and so forth. So this is actually really, really useful. I don't know if any of you have used stat transfer before. I'm not even 100% sure if stat transfer still exists, but back in my day, stat transfer was a product I think that Stata created, which allowed you to read in lots of different file types and export lots of file types. You had to pay money for it, etc. With R here, these import and export functions allow you to read in and export and essentially do what stat transfer does, which I think is really quite fantastic. So again, easy to read in the data of any type, including Stata data files, as well as export to these data types. Now, the last thing I want to show you, and then we're going to take a break, is R's native file format, because it actually has some advantages that you don't find in other statistical packages, including Stata, right? This is actually, I think, a very powerful feature in R. So to illustrate, we're going to load some data. And the command to do this is called load. Now you might, first off, why don't you say, well, Andrew, you just told me that we should use this command import from the real package, and that's true. That will work for almost every single data type. And technically, it will work for some types of R data files as well. But there's a particular advantage here to using R's native file format, which I'm about to explain. And the way that R has been designed to read these in is using this load command. So let me explain these advantages, and then I'll give you a quick rule to make sure that you can identify the best way to read in your data. So our file here again is loadexample.rdata being the extension for R data files. This verbose equals true. It just is going to print out some information when we run this command. Otherwise, it wouldn't print anything at all. And then again, the file is called load. So we run this command. A couple of things print out over here. Now, there are two things I want to draw your attention to. First, I told you earlier that in order to get things into R, you have to, I'll scroll up here for a minute, right? You have to run a command or a function, and then you have to store the results in an object using one of these assignment operators. And that is almost always true. This is one of the exceptions. And the reason is that these R data files, they contain R objects already. So we don't have to create R objects because these R data files already contain R objects. And what the load command does is it goes out and it gets those objects and it brings them into your user workspace. So you don't have to create it. Hence, no assignment operator. In this case, it has loaded in 4 different objects. I've named these objects to sort of indicate what types of objects they are. There's a data set, right? So just like a full data set. There is a vector object, which is like a single column from a data set. There's a matrix, as well as a custom function that has been that I've written. So I want to point out what just happened here because I think this is fairly unique and pretty incredible. R data files will store R objects, but in R, everything is an object. Everything is stored in an object, which means you can store almost anything that R produces in a single data file. So if you are running an analysis and you read in a data set, you have your original data set, and then you create a coded version of your data set, and then maybe you create a multiply imputed version of your data set. And then you create a couple of custom functions that help your analysis, and you run some regression models. All of those get stored in objects, and you could then just take every single one of those objects, store it in a single data file, and when you come back the next day, you load that R data file, and everything is back. No loading different types of files for different types of things. So again, this is something that Stata does. You can put data in one type of file. You can put regression results in a different type of file. R, they're all objects. You put them in a single file, which then makes your life really, really easy, both in terms of picking up where you left off, but also in terms of sharing, right? So you can imagine working with a collaborator and you've collected all of these results, different versions of the data. You can share the R data file. They can read it in and they have everything that you have. So I think these R data files are quite powerful. I encourage you, if you start working in R a lot, to save your results, save your objects, save everything in these R data files, because it makes your life really, really easy. Speaking of which, you create R data files using a command called save. So you can just list out all of your objects. So we have example data, we could put D in there, we could put vector object. And again, notice 2 data sets as well as 1 different sort of data object in here. It's all going to be put in a single file. I'm going to call it myobjects.rdata. And again, what R will do is it will write these and store these in my working directory, which is my course data file. So if I run this line of code, and again, we know it ran okay because, no errors popped up over here. And now we can take a look over in our R for Stata folder, and we see that I now have an R data object called myobjects.rdata, which if I read it back in, it would read in all of the objects that I put in it with the same names, right? So I read back, I read this file back in, I would have an object called example data, I'd have one called D, I'd have one called vector object. So I want to talk now about some basic data structures in R. And again, if you're following along in the notes, which is a great thing to do in case you miss some of the code or you need to compare the code that I have written to what you've written, this is the section, it's called Basic R Data Structures and Types and Stata Equivalents. All right, so what we're going to do here, so we'll call this Basic Data Structures, is we're going to load in some new data to work with here. Again, these are data that are in that course data folder. We've already set our working directory. So this, we can just list out the data file here. You'll notice that it's R data. Anytime you use an R data file, you use this load command. If it was anything other than an R data file, you would use that import command from the Rio package. So we load this in, and you'll see that it says over here, it's loading an object called crime. So crime is our data object. If we take a look up here in the environment, again, up here on this environment tab, actually, I think this will work here. Yeah, up here on the environment tab, you'll notice we now have a data object called crime, has 51 observations and 10 variables. These are actually data that I think they were used in a textbook, Statistical Methods for the Social Sciences, Agresti and Finlay, if you're familiar with that. But that's who I borrowed the data set from. All right, so the first thing I want to show you is how to look at the classification of an object. And the command that we use for that is called class. It's short for classification. So our data object is called crime, right? That's what we learned over here. So we're going to take a look at the classification of crime. And we see over here that the classification of crime is a data frame. Now, all our objects will have a classification. This is basically the type of object that it is, and R will do different things depending on the type of object. Data frames are R's workhorse for storing rectangular data sets, rows and columns. If you're interested in taking a look, you can use this command called view. Capital V, R is case sensitive, just like Stata. I'll scroll that up to make it a little easier to read here. And what that will do is it will just pop up like a little spreadsheet, right, where you can look at stuff. You can't edit stuff in this spreadsheet, which again, in my opinion, is very good. You don't want to change your original data. You want all your changes to be in your code file. But this allows you to get kind of a classic rectangular view of your data set. Now, to get an overview, about your data, you can use a command called str. It's short for structure. This will actually give you kind of the internal structure of any R object. When it's a data frame, it gives you, it tells you up at the top, this is a data frame, tells you the number of observations and variables. And then it tells you, after these dollar signs here, the names of all of the variables, as well as some basic information about those variables, right? So these data are, I think, various crime-related statistics from states in the United States from, a couple of decades ago. Something to pay attention to here is after this colon, you'll see these little 3-character codes, num, chur, num, etc., and as well as one called factor. These are different data types, right? These should be quite familiar. They're very similar to what we have in Stata. Num stands for numeric data. CHR stands for character data or string data. It's a basic distinction that's going to matter in terms of how you code your data in R, just like it does in Stata, so no difference there. For numeric data, you might occasionally see INT. It stands for integer. It's just numeric data. You don't need to worry about that. That's like internal R, how it's stored on your hard drive kind of stuff. One thing that is a little different are these factor variables. Factor is R's data type for storing categorical data. Nominal data, ordinal data, levels of agreement on a Likert style question or religious affiliation or things like that, right? Now, Stata doesn't have an equivalent factor data type. What it does is it has labeled numeric data, which you can then treat in some of your analyses as categorical data by using that little I dot prefix. Here you can actually store the data as a factor type of variable. All right, so that's just some basic, take a quick look at your data stuff. If you want to access a variable, you do it like this. Let me show you what this does. So what this has done is this has gone into our data set and it's pulled out the variable called poverty and it's printed it out, right? So these are all of the values, for the 50 states, plus I think they have District of Columbia. So 51 observations. These are like poverty percentage of the population of poverty. The more important part for us is what this code is doing here. Before the dollar sign is the data frame that we are interested in getting a variable from. The dollar sign can sort of be read as saying, hey, R, give me this variable, and then poverty is the name of the variable. So to access a particular variable, there's actually 2 parts in R. You need to identify the data frame that you're working with, and then you need to identify the variable. Now, this is an obvious difference with Stata. The default procedure in Stata is to read your data set into memory. And then because there's only one data set in memory, you can just refer to variables directly. Saves you some typing. And that's actually really quite handy and convenient. R can't do that because R data is just another object, right? Which, as we've seen with that save command, the fact that data is just another object and everything is just an object has some advantages, right? You can save them in a single data file, for instance. But a disadvantage is if you just say poverty, it's going to think poverty is the name of an object and it won't know where it is. So you actually have to tell it, hey, this is the data object, crime, and within that data object, there is a variable called poverty. And of course, that makes sense when you consider that you can have multiple data sets in memory at one time, as for instance, we do. We have a data set called crime, we have a data set called D, we have a data set called example data, all of which might contain variables and possibly variables with the same name. So it's a bit more typing, but that's the price for the flexibility of being able to have those multiple data sets in memory at the same time. Any questions about that? I'm about to go a little meta and talk about some more of these differences between R and Stata. But before I do that, are there any questions about this?
I also can't find the hand raising function. But why is it that you can write crime and not crime two when the data set is called crime two?
Aha, this is a great question. So crime2 is actually the name of the file on my computer. So, well, the full name is crime2.rdata. So if I were to go look, in fact, we can do it right now. If I go look on my computer, right, here's our course folder. There are a bunch of different files with a bunch of different names. There's one called crime messy in 2 different versions. There's one called crime. There's one called crime2. These are just file names on the computer. When I read them into R, there is absolutely no reason why the name of the file on the computer has to match the name of the object in R. So when I load this, it prints out the actual name of the object. In this case, it's called crime. It could have been called D or data or my data or really anything else. Does that make sense?
Yeah, and whoever made the data set named the object crime.
That's right.
Okay, thank you.
And yeah, and if you absolutely hate the name of the object, you could, you could say, oh, I hate the name of this object. I want to call it D. I actually, for this reason, incidentally, the fact that you have to type the name of the object and then the name of the variable, I've gotten in the habit of naming my data sets by default to D because it's really easy to type. So if you wanted to name it D, you would say D equals crime. You have just created a copy of the entire object called D, right? You can see it up here. They both have 51 observations, 10 variables, etc. So that would be the simple way to rename an object. You just create a new version of the object, and if you need to, you can just remove the other object. And there's an example in the notes if you actually want to remove specific objects about the way to do that.
Thank you.
Yeah, no problem. Okay, so let me go a little meta on some of these differences between R and Stata here for a minute. So we've talked about the difference between or the similarities between these different data types in R and Stata, numeric, string, those sorts of things. That should be pretty familiar if you're used to working in Stata. One thing that's worth pointing out that you're probably sort of intuitively picking up by this point is that R has a lot of flexibility, but the flexibility always comes with a price. And the price is needing sometimes to do a bit, like type a bit more in your code. And sometimes it's needing to have a wider familiarity with what R is doing in order to get R to do what you want it to do. So as an example, in Stata, you can actually do quite a lot just by reading in some data and running some commands. It takes care of a lot of the work behind the surface. You don't need to know, under the surface, how is Stata storing my data set? How is it running the command? You don't really need to know that. R can be a little bit different. It's this object-oriented language, and you do things by finding and manipulating objects. What that means is you often need to know a bit more about the sorts of objects that you're working with. You'll see as we move on that sometimes when we use a function to modify our data or to make predictions from a model, one of the ways that we specify options for that function to control how it works is to actually create other little objects. So sometimes they'll say, you need to supply this as a vector of names. So you have to know how to create a vector of names, or supply this information as a list. You need to know how to supply that as a list. Now, again, what we're going to be doing is fairly basic, and you'll see the places where this starts to crop up. But that's worth noting, right? Like R is often described as having a steeper learning curve, and that's part of the reason, because it assumes that you have a better familiarity with these basic data structures in just your normal workflow. All right, so that's meta point number one. Meta point number 2, I'm actually going to switch back to the slides here for a minute. And this is just to make sure that we're absolutely clear about how R manages these data sets. So let me open up our slides here. So in R, so again, everything is stored in objects. What that means practically is that you can have, as we actually demonstrated just a minute ago, you can have multiple data sets in memory at one time. Stata by default doesn't do that. That means anytime you want to, read in another data set, say you're working on a paper with where you're running analyses on multiple sets of data, right? Or you need to merge in data and you need to do some coding on each of those data sets. You would actually need to read it in, make your changes, store it to a file, read it in, make your changes, store it to a file. And that's how Stata's worked, right, for a really long time. What that means, so, up here, we have a data set. R will import it into an object. The equivalent in Stata is sort of import it into your workspace. But that means if you have another data set, it's going to replace that data in your workspace. R, you can have them existing simultaneously. Now, again, the downside is you have to type more in R because you have different data objects. Stata allows you to bypass that. The advantage is that it actually makes it much easier to work with multiple data sets, things like merging data, coding multiple data sets, having multiple versions of your data that you can switch back and forth easily between. That's all much simpler in R. So again, flexibility, but there's a price for the flexibility.